Alright, section 4.7 is on optimization. Usually, what happens is that you have a problem with a set of constraints and you want to be able to optimize the solution, meaning find either the maximum or the minimum. So let's take an example. Find the dimension of a rectangle with perimeter (64 meters), whose area is as large as possible. Usually what we want to do for this kind of problem is to, one, find two equations, two, make it into one equation by substitution. And then three, take the derivative and solve. All right. In this case, our two equations, well, given the problem, is going to be a perimeter equation and an area equation. So the perimeter of a rectangle, we'll say that's P, is going to be equal to 2 times the length plus 2 times the width. It's a rectangle. And the area of this rectangle is going to be length times width. We want to find when is the derivative of the area equal to 0. Why? Because this precisely gives us the max length or width. So we do just that. We need to find A prime. A prime is made up of L and W. So we try to solve the perimeter equation. We know that the perimeter is 64. So let me just solve for L. So that's going to be 64 divided by 2 is going to be 32 minus W. I will substitute that back into the equation for the area. That is L, so instead of writing L, we'll write 32 minus W and times W. Multiply that out. And then, there we go. Let's find the derivative. With respect to W, in this case, that's going to be just 32, the first term. The second term is 2W. Set the derivative equal to 0. And so we have that W is going to be equal to 32 over 2. In this case, 16 meters. So what this is saying, it is saying that in order to achieve a max area, we have to have the width being 16 if the perimeter is 64. However, of course, we are looking for a dimension, meaning we are looking for both length and width. We know the width, so let's find the length. And we can just go back to our perimeter equation for this. We know the width as being 16. So 64 is equal to 2L plus 32. 2L is equal to 32. L is equal to 16. This means that to get max area of a rectangle, with perimeter 64 meter, the rectangle itself has to be a square. Must have length equal to 16 and width equal to 16. In other words, a square. So just to re-emphasize how to solve this problem, let's take a look. To find the dimension of a rectangle with perimeter 64 and maximal area, we find two equations, make it one equation by substitution, and then we take the derivative and solve. So we find perimeter, we find area, we substitute and we solve on the right hand side. We set it equal to 0, and then we solve and we get that the width is 16. Afterward, we'll go back and we put into the perimeter equation to solve for the length, and we have that the length is also 16.